Okay, so welcome back to our video on the integration formulas which involves exponential functions. So the last video that we derived the integration formulas which involved exponential functions. Now in this video, we will have a simple example in which we can apply those formula. So we have here the integral of sine 3x e to the cosine 3x dx. So we will try to integrate this integral. Okay, so the very first thing to do if we are going back to our formula, so we have the integral of e to the u du is equal to e to the u plus c. So what is important to note in this formula? So the very important thing to note is that you must know what is your u. And upon knowing that what is your u, you will try to find the du or the derivative of that function. And if that function or that du is equal or can be found to the given integral, then you can apply this formula. So let's try it with our given integral. So in this integral, what is our u? So our u is cosine 3, what the s? 3x. I almost forgot the s. Cosine 3x. You might ask, sir, why it is cosine 3x? So going back to the formula, that is e to the u. So this one also is e to the cosine 3x. So it must be our u is equal to cosine 3x because you can say that this is e to the u. Now we will get the derivative. That is our du. So du, what is the derivative of cosine 3x? So that is negative 3 sine 3x. So let's check. So we have our u cosine 3x, which is e to the u. So this is our u. Then our du, which is negative 3 sine 3x. So we have our sine 3x here, and we have our dx. So I forgot to put dx because we are getting the derivative. So we must put dx here. So we have negative 3 sine 3x dx. We have our sine 3x here, and we have our dx here. So you might say, sir, it is not complete. We don't have negative 3 for our du. So we could not apply this formula. Note that if the only lacking term or the only lacking part of your du is a constant, so you can multiply the given integral with the reciprocal of that constant. So we can now rewrite our given integral. So multiplying with the reciprocal of the constant. So the lacking constant is negative 3, and the reciprocal of that is negative 1/3. So we could write now our integral. So let's write that one, which is similar to the arrangement on our formula. This e to the cosine x. So that is our e to the u. Then our du is negative 3 sine x dx. So you might say, sir, it is different from the given integral. But if you look closely, if we multiply negative 1/3 to negative 3, it will be equal to 1, which then the integral, our new integral now will just be equal to the original one. So we could now apply our formula. So we have our formula is e to the u du is equals to eu plus c. So we could now substitute our u to this part of our formula. So what is our u? Our u is cosine 3x. I forgot to put a cosine 3x. Okay, so let's just correct that one. So this is cosine 3x. This is sine 3x. Okay, so we could now write e. Now, but first let's write first this negative 1/3. So negative 1/3 times e to the u, e to the cosine 3x plus c. Or if you want to have a much more simpler answer, so you can negative e to the cosine 3x over 3 plus c. And that is now our answer. So hope you understand this example of the application of the integration formulas which involved exponential functions. Please subscribe and see you on the next video.